Okay. All right, let's get started. Let's look at Chatelier and Q and K or something. This is going to be real short. I guess you can tell by the minutes sitting next to it. I don't know how many minutes it will be yet, but this should not take long. Okay. So let's look at some relationships between Q and K. Hopefully you've already figured some of this stuff out, all right? We solve for Q when we do not know if we are at equilibrium or not. That's when we have an original set of conditions where we have reactants and products and we don't know which direction the system is going to proceed. So we solve for Q the same way we solve for K. If Q, over to the right, if we see that when we solve for Q that Q is less than K, what that means is we have yet to reach equilibrium. So this reaction would need to proceed in the forward direction, right? We would see an overall shift towards products, right? I'm gonna move my head here, it's in the way. We would see an overall shift towards the products. So we would lose reactants and gain products. If in fact Q is equal to K, we have no net shift. Remember, we're still moving in the forward and the reverse direction simultaneously at the same rate, but those rates will continue to be equal, right? If we see that Q in fact is greater than K, well, we need to infer from that that we are past equilibrium. And what will need to happen is we will need to shift back towards the left, shift towards reactants, so that we will see a net gain in reactants and a loss in products. Okay, hopefully that makes sense. Okay. Notice if we apply Q to K, we always shift in the direction of the big mouth, right? But this kind of makes it make sense. Let's see how that's applied. We have a little practice question right here. Oh, I've already got some work written down. Let me just start over. Okay, so I've got this equilibrium system. A2 plus B2 yields to AB. That's ugly B. They're all ugly. K, I'm told, is equal to 0.0455. That is equal to the concentration of AB squared over AB. That is both. Okay, let's just continue. I see that I've got 2 moles of this, 2 moles of this, 3 moles of this, and they are all in a 10.0 liter container or water container. So the concentration is, I'm not going to use brackets right here, is 0.200 molar, 0.200 molar, and this is 0.300 molar. I can now, I don't know, right? That's my initial. I need to do my change. I don't know which direction to go. I cannot assume it's going forward. So I need to solve for Q, right? Q is going to be 0.300 squared over 0.200 squared or times 0.200, right? Q is going to be equal to 2.25. When I compare Q to K, I see that Q is actually much larger than K. So this reaction will shift towards the reactants. And I'll see that I will gain reactants while I lose products because I am shifting towards the left at equilibrium. This will be 0.200 molar plus X, 0.200 molar minus plus X, 0.300 molar minus 2X. So I'm going to plug that into my equilibrium expression. I'm going to solve for X. I've got 0.300 minus 2X. Remember, those are concentrations squared over 0.200 plus X. That will be squared because it's times itself. We will solve this by taking the square root of both sides. That will leave us with 0.21331 is equal to 0.300 minus 2x over 0.200 plus x. We simply need to do some algebra here. 0.21331 times 0.200 plus x equals 0.300 minus 2x. That's going to give us 0.04266. 15, because I kept a lot of numbers, and that's going to give us 0. Oh, yeah, my bad. 21331x equals 0.300 minus 2x. Let's go ahead and combine some like terms, and we get 2.21331x equals 0.25734. And that gives us an x that is equal to 0.1163. So the concentration of A and is equal to the concentration of B is equal to 0.200 plus X is equal to 0.31163. And that is a molarity. If we multiply it by our volume, we will have our moles, and we see that that is 3.12. 3.12. Hold on. Put a 116. It's just 16. Sorry, I'm copying my work. Does it? Hold on. Just make sure. Let me just look at this. We got a 0.3, 0.2 plus 0.116, right? I just lost my place in my notes. 0.2. I think I did it wrong right there. 0.2 plus 0.116. Brain dead. 0.316. 0.316. Is that what I wrote? 0.316. Okay. So anyway, this is 0.316 moles of A. Nope, no brackets. Of A2. Of A2 and B2. Okay. Then the concentration of AB we said was equal to 0.300 minus 2x. That's 0.300 minus 2 times 0.1163. And that's going to give us 0.0675 concentration times 10.0 liters equals 0.675 moles of AB at equilibrium. All right. So the biggest point there was we needed to solve for Q to see in which direction this system would shift in order to establish equilibrium. And we saw that, in fact, it would go this way. So we knew to go plus, plus, minus. All right, last one, almost the same. We're going to run into a problem, and I'm going to just show you what we would do. All right. Now, we've got 1.23 moles here, and that is in 3.0 liters. We've got 9.71 times 10 to the negative third moles, and that is also in 3.0 liters. So when we get our concentration, this will be 0.410 molar, and this will be 0.0307 molar. Now, I know according to my question, I just made a mistake. This is my K value here. This is my moles here. So this is 0.0903 K, sorry, I'm going too fast, equals 9.71 times 10 to the negative third. And we know that is equal to AB 2 squared over a to b 4. All right. Now we have an initial system. We've got initial circumstances where we've got both reactants and products present. So once again, we need to solve for Q to see how Q relates to K. All right, so let's just plug those in. We got 0.0307 squared over 0.410. All right, when I put that into my equation, I get a Q, or when I put that in my calculator, I get a Q value that is 2.2 times 10 to the negative third. Well, that looks like Q is slightly less than K. Therefore, I will shift in the right direction. So I know I will lose this and I will gain this. And at equilibrium, it'll be 0.410 concentration minus X. And this will be 0.0307 concentration plus 2X. Let's look at how this goes. We now know that K, because we need to solve for X, is 9.71 times 10 to the negative third. That is equal to AB squared, 0.0307 plus 2X squared over 0.410 minus X. All right. Now, what that's going to give me is 9.71 times 10 to the negative third multiplied by 0.410 minus X equals 0.0307 plus 2X squared. And when I start solving this, all right, I'm going to end up with 9.71 times 10 to the negative third multiplied by 0.410 minus X equals that whole thing is squared, so 0.0307 plus 2X times 0.0307 plus 2X. And guys, what I'm going to end up with, right, I've got this right here, is 9.06 times 10 to the negative fourth minus, doesn't look, oh, no, let me just show you here. So let me, this is a FOIL system, right? You have to FOIL this guy. And I end up with, after I FOIL, I haven't even done my reactants yet. I have, assuming I'm right, 9.06 times 10 to the negative fourth plus 0, let me make this smaller. Okay. That's where that goes. Plus 0.602X plus 0.0602X plus 4X squared. Now, this is a problem, right? It's not really, but what do we need here? We will need the quadratic equation, right? By the time we continue to simplify this, we're going to have x's, we're going to have x squareds, we're going to have numbers. Now, Miss Murphy is not going to use the quadratic equation. I know how, because I have practiced it. I do not know how to put it in my calculator, but right, I'm not going to continue. We need the quadratic equation to solve. This will not be on your AP exam. Okay, but what I wanted you to see is that's what we would need. Okay, we can't solve this problem without utilizing the quadratic equation. Feel free to proceed. I personally have literally about 40 more videos to make, so I'm going to let you deal with that. Biggest point is dealing with Q and K and understanding when to do it and what to do. Okay, thank you guys. We'll see you soon.